Welcome to the AI Research Roundup. I am Alex, and today we're looking at a paper from the Papers with Code trending list, published on the 11th of June 2025, which introduces a new framework that claims to generate higher quality and more diverse 3D objects from a single image than previous methods. The paper is titled, Efficient Part-Level 3D Object Generation via Dual Volume Packing. So, the core problem this paper tackles is that most 3D generation models create objects as one solid piece. This makes it really difficult to, say, move a chair's leg or open a car door in the model because the parts aren't separate. To fix this, the researchers propose a new end-to-end framework. This just means it's a single streamlined process that goes from an input image directly to a finished 3D object. Their key idea is something called dual volume packing, which cleverly arranges an object's components into two special volumes. This method allows the model to generate distinct, semantically meaningful parts. Parts that make sense, like wheels and doors, that fit together perfectly. And as well see, the results are pretty impressive. And for those of you who want to try this out, it's great to see the researchers also release the official code for this work on GitHub. You'll find pre-trained models and clear instructions for running inference, which is just using the trained model to generate new 3D objects. They even included a Gradio app, a simple tool that lets you build a web demo and try it out yourself locally. Okay, and this first figure really shows off the whole process beautifully. At the top, you see it starts with a single image of a character, and in just 30 seconds, it produces a 3D shape where all the components, the face, eyes, and limbs, are separate, complete parts. The next row demonstrates its generalization capability, successfully creating varied objects like a spaceship and a dragon from just an image. But the real payoff is at the bottom. Since the parts are distinct, you can articulate them, like turning a truck's wheels, or even edit the model by removing a component, like the hair on that statue. Alright, so that's what the method can do. But how does it actually work? This next figure gives us a great look at the core idea, which they call dual volume packing. First, on the left, the system builds what's called a bipartite graph. This is basically a network map where each part is a point, and a line connects any two parts that touch. The system then sorts all the parts into two distinct groups, shown here as blue and yellow, making sure no two parts in the same group are adjacent. Then comes the packing. All the blue parts go into one volume, and all the yellow parts go into another. Because of that clever sorting, no pieces within a single volume touch, which lets the model generate them as distinct components, ready for assembly. So that's the theory, and this figure shows us the actual network architecture that makes it happen. It starts with an input image, which a Dino v2 encoder analyzes. This information then guides a flow model, which is a type of network that transforms random noise into a structured representation. Specifically, it creates two sets of dual latents, which are compact blueprints for our object's parts. Finally, these latents are passed to a variational autoencoder, or VAE, which decodes them into those two separate 3D volumes we saw before, giving us the final, assemblable parts. Alright, so that's the architecture, but a really neat benefit of using that flow model in the pipeline is its creative flexibility. It doesn't just generate one static object from an image. This figure shows that from a single input picture of a snowman, the model can generate a whole range of diverse results. You can see how each generated snowman is a bit different. Some have different colored hats, others have varied scarves or facial expressions. This is possible because the process starts with a random seed, a small bit of initial noise, and changing that seed leads to a unique but still plausible 3D model every time. Okay, so we've seen how the model can generate diverse results. But how does its quality stack up against other methods? This next figure gives us a direct, side-by-side comparison. On the left is the input image, followed by results from two other models, TripOS-G and HI3D General, and finally, this paper's model. You can see that the new model's geometry is very competitive, capturing fine details like the chair's legs or the shield spikes really well. The crucial difference is that this new approach produces a fully textured object made of distinct, individual parts, not just a single geometric mesh like the other two. As we've seen, this new model really holds its own in terms of quality. But it's the part-based generation that's the real game changer. By using that clever dual volume packing technique, the researchers have created a system that doesn't just make a 3D model. It makes a 3D kit. This approach to creating structured, assemblable objects from a single image is a big step forward for more interactive 3D content. That's all for this week's AI Research Roundup. Thanks for tuning in. I'm your host, Alex.